through the same type of experiment. How else am I going to be able to acknowledge the contradictory information that I've got through an experiment? You know, if I drop a ball and I say that this ball fell based on mass attraction, you can't tell me that I'm wrong just because you decide that you did your experiment wrong. You have to drop a ball too and explain better. You know, you have to be able to show better. And that's what I want. I don't want you to keep telling me that I'm wrong, Ted. I want you to use the science that you and I both respect and appreciate to show me why I'm wrong. That is what's important. We're not, you and I are, you may be going to college to become get degrees and stuff in it. I'm probably never will be able to, but you and I have a respect of science based on our non-university academic level of understanding of it. And that's what I respect about you and the rest of the people on Facebook. You're not just reiterating what you're learning in school. And I don't want you to just reiterate what you're learning in school. I want you to take the science to the next level. That's the only way that innovation is going to come across. You know, if I'm right, think of the possibilities. You know, I mean, how would that shape our world if we've been going through life with this principle incorrect? I mean, how interesting would it be if I'm right and the HLZ is run all this data based on backwards mathematics? 1 plus 1 doesn't equal 2. It should be -1 plus -1 equals -2. How interesting would that be in our society if that's the case? If it's that simple. If they can't find the Higgs boson simply because opposites repel and like charges attract. Billions and billions of dollars, and it's that simple. You know? And I'm not saying that because I feel like I'm this great person that knows it all and all that. I'm not a righteous person. I'm just an individual that has an understanding, and I'm applying my understanding. I can't wait till someone shows me where I'm in error so that I can move forward in this understanding. You know, so I do respect you. I don't like being told that I don't like being accused of being a liar because I don't go on my way to deceive others. I make my videos specifically without editing them so that I don't come off as a liar. I think that I'm kind of, stubborn. And it's very difficult for me to change my understanding when I have a set understanding, when I establish my understanding. It takes more than for someone to just walk up to me and say, you should stop thinking the way that you think and start thinking the way that I want you to think. Because I've lived life for a very long time, and I've come to understand that people can tell you to do things and you can obey them, but at the end of the day, you're going to be accountable for your own actions. So a person can tell you one thing, and then you can act on that information, but at the end of the day, you're going to be accountable for that information. So I choose to act on the information that I choose to understand. And the statement itself seems kind of arrogant and backwards for scientists, but the reality is that if you're going to be held accountable for an understanding, it's better for you to be held accountable for your misunderstanding than to be held accountable for someone else's misunderstanding. And if someone can't bring you enough information to help you validate their own understanding, then you should question their understanding, which is why I want you to question my understanding. If I'm not giving you enough information for you to validate my understanding, you should question my understanding. That's what I want you to do. But I think it's important for you to at least test my understanding. At the end of the day, I would at least test another person's misunderstanding. I do it all the time. So, and that's pretty much it. I don't want this video to be too long. It's going to take a while to upload it. So, just keep going. And before I go, I want to say this verbally. Clockwise spin and counterclockwise spin. If a clockwise spin causes an influence that causes a separate clockwise spin to move away from each other, while causing an influence that causes clockwise and counterclockwise spins to move toward each other, then the inverse of the above description is as follows. A clockwise spin causes an influence that causes clockwise spins to move toward each other, while also causing an influence that causes clockwise and counterclockwise spins to move away from each other. What that basically says is that if a proton causes an influence that causes an electron to move away from each other, while causing the same influence that causes two protons, that causes the same influence that causes a proton and an electron to move toward each other, then the inverse of the above description is as follows. So the first description is describing the first rule: opposites attract and like charges repel. So you have protons and protons, they have the same spin, so they're moving toward each other. If you have a proton and an electron, they have opposite spins, so they move away from each other. I'm sorry, I said that all backwards. If you have a proton and they have the same spin, they're going to move away from each other. And if you have a proton and an electron, they have opposite spins, so they're going to move toward each other. That's what the first rule says. It says if clockwise spins have an influence, it causes separate clockwise spins to move away from each other. Then that's basically saying that like charges repel. And then at the same time, it's causing an influence that causes clockwise and counterclockwise spins to move toward each other. That's saying that like charges attract. So that's what the first part of the statement says. The second half says clockwise spins cause an influence that causes clockwise spins to move toward each other. So two attractive forces are moving toward each other, while also causing an influence that causes clockwise and counterclockwise spins to move away from each other. So now like charges, so clockwise and counterclockwise is opposite charges moving away from each other. And it's basically, it's showing you how the inverse rule works. If opposites attract, like charges repel. If like charges attract, then opposite charges repel. That's the inverse. The inverse rule for opposites attracting, like charges repelling, is the inverse of opposites attracting and like charges repelling is opposites repelling and like charges attracting. That's the way the inverse rule works. It's a mirrored opposite, and that's where I think the confusion comes in. If you have a line with if you have a Cartesian plane with coordinate 0 and you move to location 1, the opposite of that would be -1 if you're at location 0. But if you're at location 1, then the inverse of that would just be simply 0. And that's where the inverse rule is a little tricky compared to just a opposite. It's a mirrored image. That's why I chose the video that I chose on YouTube, because the blue line represents, the red and blue lines represent the inverse of each other, not the mirrored images of each other, because remember, it's a Cartesian plane, which means that they're not just opposite of each other, they're in opposite coordinates as well. So they're more than just opposite of each other. If they were just opposite of each other, then it would have been in the same exact coordinate, in the same exact quadrant. It would still be in the, I think it was the negative positive quadrant. But because it was the inverse, it was in the negative quadrant. And I think the first one was in the positive quadrant. The second was in the negative quadrant. And it's not because they're, it's not the mathematical Cartesian plane inverse was represented the way that it was, not because the numbers were just negative to each other. It's because the numbers they're literally opposite of each other. They're opposite reflection. If you're standing at location A and you mirror yourself, you would be mirrored in location B. But if you're standing in location B and you mirror yourself, you'll be in location A. If you start at location A and move to location B and inverse yourself, if you don't start at the same origin and you start at the other origin, then you will just wind up back at 0, because the inverse is more than just opposite. The inverse is mirrored opposite, and that's where it gets a little tricky. So, and I think I've rambled on enough, so I'll try to get this video uploaded as soon as possible, and I appreciate your time. I don't know what else to say. I'm sorry I'm frustrating you, but I think that you can save yourself a headache by just simply doing the 5-minute experiment. Get some magnets, get a camera, record it, do the experiment. Write down the data the way that you want it done. Do the experiment the way that you want me to do it. I'm not you. I don't know exactly what information you want from me, but you have the experiment. Get the information that you want from me through the experiment yourself. And I should be able to defend my own position, but I'm not you. I don't think the way that you think. I think the way that I think. Science is about eliminating one's own bias. I eliminated my own bias. I don't know your bias. I can't eliminate your bias because I don't know what your bias is. So you have to address that yourself, Ted. And I hope that you do. I hope that you find this actually to be very, very interesting once it's all said and done. Because this is really your first scientific debate. Well, maybe not your first, but it's definitely one of them. So, as always, my name is Paul Emerson, and that is my 2 cents.